Okay, are we live? Let's find out. That all seems to be working. Good. YouTube is waving at me about things. Okay. And hopefully that's reasonably readable to people. If it's not, then let me know. Thank you, Bob, for letting me know that you heard. I apologise if you continue to hear me. Okay. I'm a bit quiet. Let me see if OBS has some better settings. How about now? How's that? That should be a little louder. I'm going to assume it's good. Okay, so my plan for tonight is to look at the Remote Execution API's content addressable storage and see if I can knock up anything approximating a client for it. I was going to try and use BuildGrid as a server, but it seems to go boom, which is, really nice of it when I try to start it up. So I'm not entirely sure how safe this will be. The controller appears to have started, which is, I suppose, the primary thing that I care about. So what is remote execution? Remote execution is a set of APIs that the Bazel team in particular set up, and it has a number of endpoints in it, some to do with actually executing stuff remotely, as you might expect from the name, and some to do with uploading and downloading content that you can use for those executions. So I figured that it might be a nice way to learn about doing some gRPC in Rust if we were to have a go at doing a client for this in Rust. So, to my knowledge, the APIs are under here. Remote execution v2 proto. So these protocol buffers and gRPC services define remote execution. As you can see, there's an execution service here, and it has execute requests and wait for execution. There's an action cache, which is to do with storing operations that happen there. And then here's the one that we're actually interested in, the content addressable storage. There's all sorts of stuff again here. We're going for the very basic, let's just have a go at hacking at it. So I'm not going to go into huge details of what the CAS is unless people are desperate to know. I'm just continuing to scroll through to see if there's... Yeah. So there is this capabilities service, and it strikes me that a good thing to start with would be to have a go at getting the capabilities of the server and just dumping that out so that we can see what's going on. That looks like a fairly simple request. There's a get capabilities request structure and a server capabilities return structure. So step one is just to get these protocol buffers in place and working. If we scroll up to the top, these things depend on at least the Bazel semantic versioning stuff and then a whole bunch of stuff out of the Google packages. So it'll be interesting to see how hard it is to get all of these in place. So I'm probably going to start by cloning this whole repository into my code so I can base my builds from there. So let's have a go at that. So remote APIs, build Bazel, remote execution v2, remote execution.proto. That's the file that we care about. Let's grab that. I've set up a little bit just because ahead of time, because I was just not going to get everywhere. Let's pull out this stuff, drop in that, and see whether or not Rust Analyzer is going to explode on us or not. It doesn't seem particularly happy. Oh, goodness me. It would help if I allowed myself to have a compiler, wouldn't it? Let me reload that window. Of course, it's now too small. Okay. Cargo build now. Are we going to get anywhere? If at any point I'm doing something that someone doesn't understand, just ask in chat. I will glance over there from time to time to see what I can do. So our build script didn't work. Proto-C failed. Directory does not exist. File does not reside within any path specified using protopath. You must specify a protopath which encompasses this file. Maybe that's what this is. So we want remote APIs build. Let's just go for that and see if that's enough. Ooh, it's got boom. Proto-C failed. Build Bazel semver blah not found. Let's knock the build out of that include path and see if that works better. It did. Google API annotations not found. Google long-running operations not found. So we need to find these extra protos as well. Google long-running operation proto. Oh, gRPC. Let's see what it says. Where is this defined? This seems plausible. So there's a Google APIs as well. I'm sure if we wanted to, we could just get the exact files, but I'm feeling lazy. Let's just get the whole thing. Ooh, this is big. So Google APIs, Google, that looks good. Let's add that to our set of includes and see what happens now. Holy crap, it can build the protocols. We're getting somewhere. Let's have a go at... I tell you what, I'm going to change this from a binary crate into a library crate. So I'm going to call this tool CasPlay because that amuses me. And let's get a lib.rs together. So lib.rs, we want to tonic include proto, and we want to give it the name of the proto that we're interested in, which I'm not entirely sure. So let's have a look at remote. No. So remote APIs, build Bazel remote execution v2 remote execution.proto. What is this actually called? Do you know? I have literally no idea what Tonic is going to have built this as. Let's have a look in the target tree. Come on, Tonic, or is it Prost build? What's been put where, do we think? I have no idea. Gosh, how do we work this out? Let's see if we can get some docs. Docs.rs, Tonic, build. Compiles protos via Prost. Mumble, mumble, mumble. Tonic build, yeah, compile protos. That's effectively what we've done. Fails to generate. The failure is not obvious until the include fails. Mumble, mumble, mumble. But where do you write it to? It's a service. Well, I tell you what, let's just give it a stupid word. Let's go fish and see what happens. So it fails to load, blah, 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 CAS play out thing. So target, debug, build, CAS play, 560 out. Aha! So we get a lot of great big long looking file names. Let's grab them. Let's get them out as a simple list. Yoink them into our editor. And do tonic include proto. Like that, and see what happens. Failed to lower macro arcs to token tree. Do we think that Rust Analyzer has just got very tired? Oh, no, it's sorted it. Wow. Goodness me. Well, that was surprising, but whatever. It's a bit of a mess for now. Cargo build over here. Ha! Enormous pile of fail. What do we need in order for all of this to work? We must have a missing use statement somewhere. Tell you what, let's comment out all but one of those. See if we can find the... Oh my goodness me. Prost message is not implemented. Learning this stuff. Could not find Prost in list of imported crates. That will probably do it. Let's import Prost. We may have got better, but we may not. Type annotations needed. Some sort of await blocks. Could not find Prost types in the list of imported crates. There are use Prost prelude? No? Goodness me. Okay. Let's see if there's a handy hint in the tonic documentation. Feature flags, mumble, include proto. Generate it. You must specify the gRPC package name. It only works if the tonic build directory has been unedited. Mod. That doesn't look like it's going to tell us what's being expected. What was our error? Too many leading super keywords. Oh, I think we're going to need to actually fit these things into a module structure. Let's start just with Google RPC. Will that build? No. So it won't build because Prost types is not in the list of imported crates. So let's start with that. Right, so that now builds. What about if we also include Google Protobuf? Good. Google long running. So that fails because it's trying to do super RPC status. So let's have a think. Do all of these protos need to be inside a pub mod Google? Do we think that will help things along? Could not find RPC in the crate route. Interesting. So why is it going super RPC? Do I need a pub mod API around that, pub mod long running around that, and a pub mod proto buff around that, and a pub mod RPC around that. Ooh, I do. You see, we're learning. Learning is good. Right, let's try and get Bazel involved. Whew. Right, pub mod Bazel. No, build. Build is the top level. Pub mod Bazel around that. Semver. And then in theory, we can dump that one in there. Remote. Execution. V2. We should be able to dump that one in there. Wow. Okay. Protocol buffers are harder than I thought. When I did some testing the other day, I just did a simple echo service that had no namespacing, and I think that was part of my cunning mistake. I wonder if we can get documentation out of this. Cargo doc. Yoink. Is this going to do something useful? Ooh. Right. Build, Bazel, remote, execution. Oh, I said V3. I'm a bit of a plonker. That should be V2. Save. Cargo doc. Reload. There we go. V2. Whew. Okay. It was the capabilities stuff that we cared about. It's capabilities client. Capabilities client structure. Wow, it's actually picked up stuff from all sorts of places. Oh, I think that's pretty cool. Okay. Well, let's just try writing a program that can talk to the build grid that I've got running locally. Okay. Let's see. Use cas play : build : Bazel remote execution v2 capabilities client. There's a start. We're going to need to get a Tokyo up in here, and that probably wants to return an anyhow result of that. And let's stick an OK on the end. So we want to get a capabilities client connected. Capabilities client : connect. What does that take? A thing. Okay. Let's assume we can give it localhost. Can I remember where build grid is going to give me a thing? It's going to give me the controller is at localhost : 50,051. 50,051. Let's go let client equals that. Well, maybe we've got a client. Client dot get capabilities takes a request object. Dot wait. That's going to give us a server capabilities response. Do we remember what the name is of what? So capabilities client connect gave us a capabilities client. Good. Get capabilities takes a request which implements whatever into request for get capabilities request is. And that's in remote execution v2. So we need to get that struct into scope. So let's say, I don't know, let request equal capabilities get capabilities request. What's its instance? Tell me the fields, right? Instance name needs to be empty. Let's stick a semicolon there. This is terrifying. We're getting closer to something. What's the bet that that implements debug? It hasn't failed. We've only got one binary. Async keyword is missing from the function declaration. Yep. Cannot borrow as mutable. Clearly we need to be able to mutate a client to make a call on it. There we go. There is the capabilities of the build grid. That took, goodness me, half an hour. I'm quite pleased with that. Okay, so what can we do? Metadata map, that's presumably all about the Nginx that's fronting the build grid. It's the message that we're interested in, which is the server capabilities. And we're particularly interested in the cache. So there's some cache capabilities there. So let's just extract those for now. And that cache caps is caps dot. Right, what can we get from this? We can borrow it. We can get its metadata. Can we get its content? What was its content called? It was called message. No. If I do that, right, that gets us the server capabilities, and then we want the cache capabilities. It's an option, presumably because the server doesn't actually have to run a cache. But we're just going to be cheap here and unwrap it. And then let's output the cache caps there instead. Just that we're focused down on the thing that we actually care about. So, what do we know about this? I don't know if things are glitching for other people. It does say the connection's okay. Here's hoping. Okay. Symlink strategy denied. Compressors is empty. Right. I mean, that looks like a pretty normal content addressable store to me. So why don't we have a go at writing some useful functions? Let's get clap involved. That will let us write a reasonable command line tool for this. Use clap. Can anybody remember how to do clap derive? Brief moment of buffering, but okay, good. I'm glad. I think someone may have sneezed near a microwave. How do we do this? We do use clap parser, and then we derive parser. Okay, use clap parser. We're going to want multiple subcommands. So let's write a capabilities subcommand, just so that we can stuff that there. So how do we do subcommands? Come on, clap, tell us how to do these things. No. Custom, so the optional feature of derive. Aha. Okay, cargo toml, clap, yoink, version equals that. Features equals, give me derive, please. That seems okay. And derive, parser, debug. What else did it suggest? That'll do. Clap, author, version about. I like just stealing other people's stuff. Struct kpub. Let's call it caps. Actually, no. Let's do the main command line. Struct CLI, and we're going to want a what's the word? We're going to want to know where we're connecting to, and we're going to want to know the instance name. So let's go. Let's have. Can I say clap default equals HTTP localhost 50,051 endpoint colon string. Is this? Oh, perhaps I need to tell it that that's also long comma. That. Let's try clap long comma default equals empty. Actually, no. Let's just do long instance option of a string. Let's see whether clap is going to scream. Goodness me. Well, that's a nasty pile. I tell you what then, let's just make the default via making that option string as well. Will that build? That's happier. Right. Let cli equal cli from cli kind of parse. Rust Analyzer is not happy in this window. Let me reload it again. I need to learn how to stop VS Code from trying to save when I zoom in. Okay. Right, so let's do let mute that, and let's say okay, cli.endpoint equals cli.endpoint dot no, that's not what I want. I'm just going to say let endpoint equal cli.endpoint dot unwrap or localhost 50051 dot 2. Will it? What is up with Rust Analyzer? It's basically not doing anything here. Tell you what, async fn real main. Let's just double check that this is not that it can't cope with it being inside that macro. No, it just doesn't like that. Cli parse. That's just, it's not liking it. We got our parser. What's going on? Doesn't like the mute. Yep, fair enough. I mean, it doesn't need to be. I'm just wondering why Rust Analyzer is being so prissy about this. Perhaps it doesn't like the clap derive. Ah, well. So we're going to pass endpoint into here. The instance name is going to be cli.instance. Cloned.unwrap or empty string. Can't call cloned on option stood string. From borrow stood string is not implemented for that. Is that implemented? Yes. Why can't I clone? Does it? Oh, it's because option doesn't have that capability yet. Never mind. .map string clone. I hate everything. My brain is clearly not in it today. So that works. If we just run it, it gets us the right thing. If we tell it instance fish, then we get an error back because, well, there isn't a fish instance on the build grid that we're running. Hurrah! We're getting somewhere. So now we want some commands. Let's see whether or not I can guess at how this works in clap when I've never done it before. Enum command. Caps. I don't think I want any arguments to that command for now. Let's just try that and see what happens. Command doesn't implement debug. Command from str is not satisfied. Okay, so we need to tell clap somehow to pull this in. Derive API. Configuring the parser, adding arguments, counted arguments, positional arguments, subcommands, example. We derive subcommand, not parser. Of course we do, and then we do clap subcommand. So, and derive subcommand. We are roughly back to where we were. And if we run with caps, we get our capabilities. Let's just move that off into a function. So let's have async fn capabilities, which is going to take a client, which will be a borrow mute capabilities client over channel, whatever that is. We'll work it out later. And it gives back an anyhow result. That, I'll tell you what, I'm fed up with typing that in, so let's go ahead and define that. Type crapshoot equals that. Let's just replace these. It's all a crapshoot in the end. So this takes a client. Should it take a config as well? It can take a client and it can take an instance name. Do we want to pass the instance name in? Let's have a useful configuration. Struct config instance name string. There we go. So it's going to take a config, which will be a borrow of a config. Should we stick the client borrow in there? Might be easier than trying to faff about the config.client. That would suck. Let's not do that. Okay. So let request equal get capabilities request instance name equals config.instance Name.clone, it's not an equals, it's a colon. Comma, semicolon. Let caps equal client.get capabilities. Pass in the request. Await. In fact, let's yoink those out entirely down to there. And then let's take all of this out of here. Let config equal. So instance name is now going to be our cli.instance name. Cli.instance, sorry. Dot unwrap or into match cli.command. Really doesn't like these derived things, Rust Analyzer, and I don't know why. No code actions available. Well, that's just weird. Command : caps becomes a call to capabilities, passing the config, and a borrow mute of the client, awaiting, and we should be good. No, what have I cocked up? Channel not found in this scope. So client is a capabilities client. Channel comes from, oh gosh, somewhere in Tonic. Did we see where channel came from? There's no Tonic prelude. Tonic transport channel. Okay. We've now got trivial thing. What's the next thing that we want to implement? We probably want to implement either file upload or file download. Which one would make more sense? I did notice that when... Ooh, what's going on here? Controller, blah, error, inactive RPC error that terminated, failed to connect to all addresses. Better picker. Worth. I have no idea. Thanks, build grid. This is definitely working well. It's this bots thing, isn't it? Well, never mind. The controller seems to be perfectly happy, though. I did notice that when the storage set up, let me see if we can find the storage. Here we go. It said that this blob exists. Checking for blob, getting blob. So, I don't know. I mean, checking blob, getting blob. Presumably that blob exists. So we could, in theory, fetch it. But I don't know how big it is, and this doesn't actually say how big that blob is. So it's probably better if we implement upload first. So we're going to have a command upload, which is probably going to take an upload struct, whatever that turns out to be. Did the clap example that we were looking at. So it just went like that. Let's find out. That is the empty blob. So it should be 0-sized. In that case, let's write download first, because, or fetch. We'll call it fetch. And fetch is going to take a name, which is a string. That'll be the quickest way to get somewhere. Now we're missing a match arm here, which makes sense. Could I please have that? And we're going to call fetch blob. We're going to pass it the config, a client, and a name. And await the result. So fetch blob is going to need to be given a configuration. It's going to need to be given a client, which is not a capabilities client. It's going to be something else. Fetching a blob. Which interface does that use? Remote execution. Fetch a tree. Fetch an action. Okay. Blah, blah. Most of the binary data is opaque. Mumble, mumble, mumble. Files that get uploaded. Something or other. Uncompressed data writes. Can be written to. How do I read from it, though? Downloads. Here we go. Data can alternatively be downloaded compressed form. Small downloads with batch read blobs. Larger downloads. Use the read method of byte stream. So we just use a byte stream client to read. And what's the format of the name that we want to use? For uncompressed data, the resource read request.resource name is of the form instance name blobs hash size. Well, we're going to use the hash that we saw before, and we're going to assume the size is 0. So we can construct that name from what we've got here. So we're going to need a byte stream API. Let's move the endpoint into here. So we just stick endpoint there. Config is going to have an endpoint, which is a string. We are, instead of passing the capabilities client in, we're just going to pass the config in. And we will create the client here. So we'll do let mute client equals capabilities client connect endpoint await. We can therefore get rid of that. We can stop passing the client in because it doesn't exist anymore. And that means we can, in our fetch blob, name, borrow a string, give us a crapshoot. Okay, so we need the byte stream read API. Let's mute client equal that was too much to ask, wasn't it? Which one is it? It's read request is from google.bytestream. Bytestream read. Okay. Use CAS play Google long running protobuf RPC. It's google.bytestream. Did we not build the byte stream? Pubmod byte stream tonic include proto google.bytestream. Are you going to tell me that that's not available? Because that would make me very sad. It's not available. Google APIs, Google bytestream, bytestream.proto. So I also want you to build Google APIs by Google bytestream, bytestream.proto. What have I done wrong? Can't spell the word capabilities. That's definitely a problem. Endpoint not found in this scope. That would be because it's config.endpoint. Cannot move. Yep, borrow it. Oh. We're getting somewhere. Capabilities. This data has an anonymous lifetime and it's required to live as long as the... Okay, right. This is starting to get angry with us. Because it doesn't like that we are giving it something it can't keep control of. Since we don't need the configuration after we have called the code, let's just not bother borrowing it. Is that going to shush it? Borrowed value there does not live long enough. Oh, for goodness sake, that would be the problem. Right. So we actually just want to clone that. So let's actually pass the borrows in like we said before we wanted to, and then let's just clone. I imagine that that endpoint is held around for error messages and the like. Good, right, and we don't need tonic transport channel now because we're not passing those clients around. So fetch blob, we need a byte stream client. Let mute client equal byte stream client ::connect config.endpoint.clone.await. So the read request is okay. Let request equal read request. And what does that need in it? Fill me the fields. It needs a resource name, a read offset, and a read limit. Offset 0, limit 0. Presumably means everything. And the resource name will be a format of... We need the instance name / blobs / and then the whole name, which we're going to get from name. So config.instance name. Who knows what's going to happen now? This is a bit exciting. Let's try and read this. So let reader equal client.read. It takes the request. Let's call that request, not just rec. And await. And what are we going to get out of that? We get a streaming response, whatever one of those is. What do we think we can do with one of those? Tonic. So tonic response. Get ref gets into inner, gets us the inner thing. We don't care about the extensions or anything like that for now. So let's do. So that gets us that streaming read response. Streaming. Blah, blah, some decoder, mumble. Message fetches the next message. So, while let sum mersk equals reader.message.await. Trailers? Trailing metadata? I have no idea what all of that is. Mersk dot, what have we got in here? We've got data. I think that's probably it. Where's our documentation for ourselves? Here. Cargo doc. Byte stream client. Read gives you a result spawn. The read response. Read response just has a data vector. Received a chunk of bytes. Let's literally just print that out for now. Can we build that? That needs to be mutable. We are getting somewhere. Cargo run dash dash fetch, and now we need that magical hash. So that was this /0 for the length. Method not found. Ooh. What do we think happened here? Are we talking to the wrong thing? So if we do caps, that tells us the cache. Why would we get method not found? Is it? Let's put a couple of blank lines in, try that, and see if there's an error message. That's whatever bots 1 is. I think it's because the servers. You are talking to the wrong thing. Am I? Oh. Do I have to talk directly to the CAS for the byte read rather than to the controller? I need to talk to 5052. Is there anything in the capabilities that tells me those addresses? I'm going to guess no, but well, that did nothing. It didn't error, but it did nothing. Does that mean we don't get a 0-byte return? I think it must mean we don't get a 0-byte return. Okay, let's extend our configuration a little bit. We'll call, so, controller endpoint, and CAS endpoint. Our configuration is going to have a controller endpoint and a CAS endpoint. Controller is just a legacy of confusing name for execution plus operations plus bots and capabilities. Okay. Let's controller endpoint equal. Let's CAS endpoint equal. It reports capabilities of everything for basal compatibility. Ah, this is the joy of hysterical raisins. This is me giggling. So, oh, all the endpoints have a capability service. So I could ask for the capabilities of the CAS itself. So I can. Screw all of these changes. I'm just going to change the default endpoint to 52. Okay, so if we do that fetch again, do we succeed? Oh, I undid too much. Mute. Okay, so we're getting nothing. So I assume that's what happens for a 0-byte thing. So we know we're doing SHA-256, so let's write an upload blob. That could be fun. So fetch upload. Upload blob, giving it the config and the name. Fortunately, it's basically the same thing here. I'm going to just assume the SHA-256 at this point because I can't be bothered. So the first thing that we need to do is we need to load this file. I don't like the fact that that's a string. That's going to be a path buff. And now I'm going to get some complaints. Presumably, yeah, I didn't actually cause that to work, did I? So import path buff, and why did I change fetch blob to be path? That's still a string because it's a SHA and a size. So upload blob here needs to be a path, and that needs to be imported. Okay, we're getting somewhere. In order to do this upload, we need to be able to hash the file. Is it reasonable for me to just load the file into RAM? No, let's try and be cunning about this. Means that we're going to have to stream the file twice from disk, but I don't mind that much. SHA-256 docs.rs SHA. It's a good sign. SHA-256. I don't like this to-do docs though. There's got to be a better hashing library. Hash says use the MD5 package instead. Hash algorithms. Let's put SHA-256 into there. So there is just a crate called SHA-256. And when you use digest, you get... Ah, that looks convenient. So let's do that. And we can do digest. Oh, I like this. That looks nice and easy. Okay. Cargo.toml SHA-256 equals whatever. Just give me it. Oh, by the way, I apologise for the brightness of crates.io. They don't have a dark mode. So let SHA equal digest file. Passing in name. So that gives me a SHA. I need to know its length. Let flen equal. I need metadata on path dot len. Convenient. Okay, so let request equal write request. Ooh, lots of things going here. Okay, so we'll call this our base thing. So data here is probably at a guess going to be an empty vec because it's probably bytes. Finished, that's probably false. Write offset is probably 0 to begin with. And the resource name is going to be the instance name. Where's our CAS documentation? Let's get rid of that. That's loud. So we looked, that was reading. So when we write into it, data can be uploaded in compressed form. No, uncompressed data. Right. Write request.resource name is of the following form: instance name, uploads, UUID, blob, hash, size, optional metadata. Okay. Instance name, uploads, a UUID. I don't know what goes here. Blobs, hash, size, config.instance name, char, and file length. If anybody knows what the I don't know what goes here is, then that would be helpful. Otherwise, you know, we are where we are. So we want a byte stream client to write to. Yes. So let mute client equal byte stream client connect to config.endpoint.clone. So we now have our client. So to write to here, I believe it's a streaming interface. I might be wrong, but I believe it's a streaming interface. So if I go client.write, write is used to send the contents of a resource. Write action is presumable if there is an error. Something query write status. When the client closes the request channel, the service will respond with a write response. It will not review it as complete until we send a write request with finish write set to true. Sending any requests on a stream after sending a request with finish write set to true will cause an error. The client should check the write response to determine how much data it was able to commit. Okay. So we're going to go response equals client.write.await. Like that. And we just have to work out what to pass in here. So what is our request? Let's have a look here. So right, needs an into streaming request of a write request. An into streaming request. What implements this? What can I do that implements one of these? Futures util stream? No, because I need to be able to read from the file. Can I do some kind of async thing? So this was a streaming thing. Into streaming request. Implementers for request T, or for T, where T is stream plus send plus static. So what is stream? That's a futures stream. Okay. What about futures util? Well, this is going to be exciting. Let's see what we can do. Cargo.toml. Pull those two in. Rust analyzer. Could not compile generic array due to 2 previous errors. Expected value found built-in attribute path. That would be because that should be name. Silly moo. Some input. For build grid, I don't know what goes here. Can be whatever you want. It just gets ignored. Hurrah! Okay, then I'm going to ignore it. So we've got futures util here now. So can I somehow, I don't know, I'm going to call that base request. Let's go let mute file handle equals file file. Ooh, I could use a Tokyo file. Yeah, let's do that. File : open. Takes the file name we want. That gets us a file. Right. We need to work out how to make a stream out of this. There's got to be something. Let's try docs.rs futures util. Macros, try join, stream select, blah, 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 blah. Modules, stream. Stream trait for things that can produce values. Enums, functions. What implements stream? Receiver. Flatten stream. These are all the stream utility types. All immediate. Is there some way that I can turn an async thing, some sort of yieldy, streamy thing? Let's go for async Rust futures stream yield. Let's see what happens. That's it's bright. I apologize. Stream : iter. That takes an iterator. Can I just give it an async function? Doesn't seem good. Is there some... Those are just print lines. Oh, this is frustrating. If anyone else manages to use their Google foo to generate an appropriate stream, that would be great. Async creates a future. Yes, yes, yes. Rust tonic stream yield. Tutorials, what a good idea. So this includes Tokyo stream. Ooh, is that where we need to look? Common way to return stream values. One or others use the async stream, which contains macros. See, we'll get there eventually. Async stream provides two macros, stream and try stream. That's the kind of syntax I was looking for. Okay, so we need the async stream crate. Let's bust those two back out and go for async stream. How are we doing with that? Plausible. Okay. So how does this work? The stream macro. See crate for more data. Fine. Stream macro returns an anonymous type implementing the stream trait. The item is associated. Blah, mumble. but the item associated is this. TriStream supports question mark notation as part of the implementation. Well, I think we need to use TriStream. It might be futures stream once. No, I don't want a once. I want to chunk this because I don't like the idea of trying to read entire files in, because I might literally try throwing an ISO image or something at it. And while I've got enough RAM, we may as well write this on the assumption that people don't have enough RAM to throw multi-gigabyte images around. So let's go for let stream equal stream pling out of there, semicolon. Oh no, it was TriStream, wasn't it, that we wanted? And the thing that we want to do is basically go, you know, let's have a let mute buffer equal vec : with capacity. Let's be deliberately obtuse and go with like 4K as our buffer size, and see how we go. So buffer dot resize, no. Set. No, goodness me. I think because it's inside a macro. Yeah, it is resize 4K with 0 U8, just to make sure we've got the buffer the right size. Then we want to try and read a chunk from the file, so fh.read borrow mute buffer. I'm basically guessing here. This Rust Analyzer has given up on me. Next. Actually, that's a point. Am I allowed to TriStream if I'm generating write responses? I think I'm not. I think I just have to stream, and then if it's bad, just stop. So we're going to do a loop, because obviously we are. And we're going to stick match there. Okay, n goes to n, error anything goes to break. We've got some bytes. So let request equal base request.clone. Let mute. Actually, no. We can. No, we do have to do it this way. Yuck. Let mute request equal that. Request.write offset equals, I don't know, total bytes. So we can go let total bytes equals 0. Request.finish write is, let's have a look. Let's go for byte count does not equal 4096. We now want to say request.data equals replace. I'm going to pick the node. Rust Analyzer has gone bonkers now, so we'll just do stud mem replace. Because I'm going to bet we have to hand that data over. And now we can, what can we? Yield request if byte count did not equal 4096, So that'll stop yielding results. Can we just pass the stream in there and then see what we can do with the response? What do we get in a response? That's all tonic. It's here, isn't it? The right response contains a committed size. So now we can go print line written blah / blah committed size blah, and that's going to be the SHA and the file length and response dot getref dot committed size. Okay, so method not found in Tokyo FS file. It is available if we do use Tokyo IO async readexed. That sounds like a good thing to do. Use Tokyo IO async readexed. Well, that's terrifying. And not at all what I expected. Let's get rid of that unnecessary thing. Place your bets now. Cargo run -- upload. What should we upload? Shell.nix. Unimplemented. Message cannot close stream before finishing write. Well, that did a check for that blob. And then the gRPC executor said cannot close stream before finishing write. What happens if... Well, no, because we did a finish write, didn't we? Before we write the data out, let's go println block like that. So our write request is that write offset 0, finish write true, and then the data. So we wrote a single block. Perhaps we're not allowed to. Let's just not set finish write. Let's do total bytes plus equals byte count. And when we come out of the loop, because we've broken out of the loop, if break false, break true. So we have broken out of the loop because we finished. So let's do a let me request equal base request dot clone request dot write offset equals total bytes request dot finish write is true, println final block yield request, and in theory that should be everything. How bad of a mess have I made? Unexpected end of input curly braces. Expected I64 found U size. Tokyo, what have you done? Docs.rs Tokyo. Async redexed. FN read gives back an IO result usize. Of course it does, because why wouldn't it? As you, what are we expecting? We're expecting an I64. What are we going on here? That error is when Billgrid's counter the bytes written doesn't match the size part of the digest. So I learned the existence of that confusing error message. Hooray! First assignment to total bytes needs to be mutable. Of course it does. So we sent a write request. I'm going to move that println there temporarily so we can check that there was actually some data in it. Ooh, we don't set the length of the thing. That's going to break. That's really annoying. Buffer dot resize byte count. Huzzah! So the error was that I wrote too much data. A better error message might be nice. However, we appear to have successfully written this thing. So can I now cargo run fetch that thing? Received a chunk of 97 bytes. It's a good start. Shall we just dump that data out? Yeah, why not? Right. No. Stood out dot write all of musg dot data. How bad is that going to be? That would be what I uploaded. We are now 1.5 hours in, and we have successfully uploaded something to a CAS and downloaded something from the CAS. I think that's pretty good. So on that note, I'm going to take a short break, and when I get back, we'll try and do some somewhat more interesting CAS things, like uploading a whole tree of files. Back in a bit. Okay, let's try and do some more. I think before we get too much further though, we should try uploading a bigger file. Do I have a text file that is bigger than 4K? I have a 35K word list. Let's try uploading that. Cargo run, upload. Claims it wrote it. That looks like it worked. I'm extremely pleased. Okay, let's get rid of some of that debug crap. So we don't need that block, we don't need that. We'll stick just with the written blah, committed size blah. The fetch looks good. So what else is there in CAS that we could usefully play with today? So find missing blobs. Determine if blobs are present in the CAS. The client can use this API before uploading blobs. Servers should increase the lifetime of the reference blobs if necessary and applicable. So we should probably do this before we try uploading in an upload. Let's try that. So we're going to need a content addressable storage client in our upload. We've done the digest, we've got the metadata, we've got this resource name. Let's see what happens. We can go if not has blob config char file length. Why am I putting the types in here? Config char and file length. Wait. So if we don't have that blob, no, let's do better. If we has the blob, println blob blah slash blah already exists in CAS char flen, so we don't need to upload it. Now let's define that has blob, which takes a config, it takes a char, it takes a flen. What did we say that was? We said that was an I64, I think. Flen is a U64, of course it is. U64. It's going to return a boolean for whether or not that's present. Okay, let mute client equal. What do we need this time? We actually need the content addressable storage client. Content addressable storage client connect config endpoint clone. And we need to make a request. What shape is our request? It's a find missing blobs request. So let request equal find missing blobs request. And instance name. This is starting to feel familiar, isn't it? Config.instance name.un. What was my approach here? Pretty sure I did it up here. Config.instance name.clone. That was it. Okay. Blobs digest. What is it? Goodness me. Right. Find missing blobs request. Repeated digest. Blobs digest. Repeated is probably going to be a vec. And it's going to be a digest. Which takes a hash, which is probably going to be char.toString, and a size bytes, which is probably going to be flen. We're getting somewhere. So let response equal client.find missing blobs of request. dot to inner. And we've got a find missing blobs response, which is a repeated digest of missing blobs. So, well, response dot missing blob digests dot is empty. Not. So we're only looking for one blob. If the missing blobs list is empty, then we have that blob. That's got to be right. Okay, let's see what happens if we try and upload that word list again. It should say that it's present in the CAS. Expected borrow, doobie-doo, of course. And what's it expecting a file length to be here? An I64. Can't be bothered to be clever about typing this stuff at the moment. Blob already exists. Written that much data. What? Oh. Let's actually not upload it if it already exists. Blob already exists in the CAS. And if we upload something that doesn't already exist, like that enormous file, it uploaded just fine. And if we try to upload that again, it already exists in the CAS. I'm very happy. So find missing blobs. We understand how that works. We're not doing anything fun with it, but meh. So what else do we have in the CAS? We have batch update blobs, upload many blobs at once. Okay. Download many blobs at once, batch read blobs. I'm not sure that we particularly care about this at the moment. Fetch the entire directory tree rooted at a node, get tree request. So this requires us to have successfully uploaded a tree to the CAS, which we've not tried to do yet. Should we try and do that? It's 8:30. How much more of this do I want to do? Adam, if you're still here, is there a convenient tool in the build grid repository to let me upload a tree so that I could try doing the get tree first? While that gets through to you and you have a look, I'm going to just have a quick look at that structure as well. So let's come all the way out to here and say, what does a get tree request look like? It takes an instance name, a root digest, a page size, and a page token. Page size, maximum page size request. If present, the server will request no more than this many items, regardless of whether the page size is specified. The server may place its own limit. Page token must be a value received in a previous get tree response. If present, it will use that token as an offset, returning only that page and the ones that succeed it. Okay. What should it be if it's not present? Because it's not optional. It's a string. Root digest is optional, presumably because if you're supplying a token, you don't need to supply the root digest again. But token, what? Get tree response. Gives you a vec of directory and a next page token. That kind of makes sense. A vec of directory represents a directory tree node, which takes a file node, directories, symlinks, and node properties. Goodness me, a directory that obeys these restrictions is in canonical form. In order to ensure two directory tree hashes to the same thing, the following must be obeyed. Every child in the directory must have a path of exactly one segment. Each child... files and directory symlinks. Node prop. So we're going to have to obey this construction if we decide to upload these things. which is not necessarily a bad thing. BGD CAS upload dir is what you want, but I've never actually used it. Oh, well, that means we have to try it. Okay, let's do it. Let's get another terminal. Build grid. So I've got a Docker compose up happening here. So presumably any of controller or storage or what have you would allow me to do a Docker run BGD. But what about... This is what happens when you install Docker and don't reload your desktop. Let's have a look. Build grid local, presumably the thing. If I do docker shell build grid :local, shell is no. Docker run --it --bin share. I don't have tocs around. I don't have a virtual env. I've literally just done docker compose up. Docker enter. Is that right? No. I've forgotten how to docker. Docker compose run in storage 1 bin share. No. I'm sorry to say I have absolutely no idea what that means. Oh, it's just -it, not --it. Of course. No such command bin share. Bin bash. No such command bin bash. Is there no shell inside build grid local? Or do I have to tell it to not use the entry point or something weird like that? Is there a no entry point flag? Override the entry point? Maybe I just do that. Aha! Right. BGD? No, of course I don't have BGD. That would be too easy. It is in there though. Source env bin activate BGD. Woohoo! Okay. BGD. Let me go and look again. CAS upload dir. Okay. Let's upload the build grid directory. BGD CAS upload dir build grid. Okay, so this is the directory digest that we've just uploaded. Cool. Let's flip back to here, and we're going to go root dir digest equals that, so that we can save that to play with later. Shall we write like ls, which is going to use that get tree to list the contents of these things? Yes, let's do that. Okay. ls, which is going to get a string. Let's get that, and we're going to go list tree config name async fn list tree. Right. So we're going to use that get tree request. What does that look like? What was the name of the API endpoint? It was getTree. Okay. We want a content addressable storage client. I'm guessing that in a proper implementation of this stuff, we'd probably want to have this thing be created once and then use it multiple times from our config, but meh. We're writing hacky code. Let request equals get tree request. So we wanted our instance name. We want our root digest. That's a digest object. Fn digest from str. Input splitting on a slash. Assert equal paths.len2 digest. The hash is going to be parts 0. And the size in bytes is going to be parts 1 parse unwrap. Theoretically, that might work. I mean, it's not exploded horribly. So the root digest is going to be digest from str name. Page size. Let's deliberately pick something small so that we're going to have to do that repeating algorithm. Let's say we want a page size of 10. Let's make the rash assumption that the default for page token will get us the start. So let response equals client.getTree. We give it the request. We await it. And we into inner to get that streaming object. What's this? I vaguely suspect you might need to redo the upload, but use docker exec on an existing container to do it in place of docker run. That's possible. Although here's the log of the controller. Did we upload a lot of things to it? Probably not. There might be magic you missed. There might. I have a feeling that there wasn't, though. So dash help. BGD dash help. Can I tell it where my remote server is? Yes, dash remote. Otherwise it defaults to localhost 5051. Which is weird. Remote. Let's come out of there. So rather than docker run, I should use docker exec on an existing container. So if I do docker ps, so that's the ID of the storage container. So if I do, actually, no, yeah, docker exec dash it that thing dash bin bash OCI exec failed. Starting container process caused error. Exec dash executable file not found. So I don't need a dash. Excellent. Source env bin activate bgd cas download file. What I'm going to do is I'm going to give it the cas name of that word list and /temp/foo. Failed pulling. Okay. Why did you fail pulling? What's this? You want the controller container. Don't want the storage container? Okay. Come back out. Docker ps exec. Where's the controller container? This one. Source and bin activate. Method not found. That seems even worse. I don't think the controller container was any better. Why did you think the controller container, Bob? Let's go back into the storage container. That at least tries to do something and fails. Can I increase the logging? There is no debugging in here. Defaults to localhost 5051. There is no netstat. Port 5051 open. I'd expect that to go. I couldn't connect at that point. Dash remote localhost 50052. Right. We're talking to the right cas now. That's good. Did I really want to upload the build grid directory that contained a whole bunch of Python files and stuff? Probably not. That looks like a better directory. Let's upload that one. So, rather than download file, we want to upload dir. I'm going to upload the data dir. And if we come across to here, there's a whole bunch of writing blobs is in here. So that is a useful top-level directory hash. Hurrah! Okay. Root dir digest equals that one instead. Right, I think we've actually got an upload, so let's continue with our thing. So we've got a get tree response here, which is a streaming result that may or may not need us to do more. So let's go for this. Let some response equal response.message.await. So we've now got a getTreeResponse object, which I think we had. That was a write response. Where were we looking at getTreeResponse? I'm sure we were. Where were we looking? Let's just look here instead. So that gives us a vector of directory objects and a next page token. Println. Okay, no. For dir in response dot directories dot iter. We've got a directory. I don't know. Let's just dump that out for now. Next page token response dot next page token. So we're just going to do this once and see what happens. Cargo run ls read digest. Expected enum option found struct digest. That's fair. That needs to be a sum of all of that. Expected vec found a studstra split. That's because I should do a collect on that. Response needs to be mutable in order that we can stream from it. That's fair. So we got 4 results with no next page token. What the heck is going on here? Okay, let's go. Got blarders response.directories.len. So we got 5 directory objects come back, which said the first one was a directory object that, whatever it is, said that it had a config thing in it as a subdirectory. I assume that is that top level data directory. So the first thing that comes back must be that top level data directory. I hope that's fair, and I'm also hoping that someone will correct me if it's not. So then we got a directory object that contained artifacts, basic with disk, bumble bumbles. Those are all of the files. That's the main subdirectory. And it also contained a Grafana directory and a RabbitMQ directory. The Grafana directory contained those things. Dashboards contains those things. Then there was those JSON files that we saw. Then there were no directories in an entry. Then there was one directory, which had that. Okay, so I have a question. How do we link these things up? As in, at the top here, we were given a directory object and it contained a thing called config, which had this hash and this size. How do I know which one of the subsequent directory objects is that? Do I have to reserialize and hash it? Because that clearly hasn't come through in the response. God, I hope not. But I have a horrible feeling I do. Okay, let's do that then. So we got a directory. We've printed that directory out. What can we do before then? Can we somehow serialize that directory? Represents a thing. It impulse clone, debug, default. It impulse message, which is a prost thing. Excellent. And we can encode to vec. And that just gives us a vec-u8 in a newly allocated buffer. That's what I like to see. Right, let enc equal dir.encode to vec. I'm probably going to get told that I'm missing some include at this point. Yep, prost message. Rust Analyzer's got very sad at this point. I think it doesn't like the combination of, you know, clap derive and Tokyo main and all of that other stuff. So in future, mental note, try to have the actual functional stuff in a separate module that hasn't got this particular pain. Use prost message. So that's hopefully encoded. Cargo build. Yes, right. So the next thing we want to do is we want to construct a digest for this directory, which means that we need to hash that vector. So let char equals char 256. So no, digest byte of enc. And then let's print line. This dir is that/that for a value of char and enc.len. Let's see if that's what we're meant to be doing. Someone somewhere will be laughing at me at this point. Okay, so this dir is 8a58 blah/81. Is that the root dir? It is. We're looking like we're doing the right thing. So this config directory is 435 blah/1979, which is the next thing. Awesome. Okay. Is it correct to say that we will not be given a directory object that we have not previously seen a reason to receive? And by that I mean we'll get like the root directory object first, and then if that references some directory node, we might get that one second, and so on. But we should never be trying to process a directory object that we don't know where it sits in the file tree. Am I allowed to assume that? Reading the Python code. That's good. While someone gives me the answer to that, I'm going to assume it's true. So I'm going to say, okay, let mute name map equals a hash map of digest to string. :new. It'll be hash map. : new. Like that. No. Well, we'll just do hash map new. And we'll say that name map is a hash map from digest to string. Think so, yes. Excellent. So what I'm going to do is every time I encounter a directory, and I'm going to take that root digest and I'm going to save it. So every time I encounter a new directory object, I'm going to theoretically already know who it is. So let's go let digest is digest boom Size bytes is going to be enc.len as I64. The hash is going to be sha. So now I have a digest object for the directory that I'm now looking at. I should be able to look it up in the name map. So I should be able to go let this name equals name map dot get digest borrow digest dot. Okay, let's just go with unwrap. It really should be there. And let's insert into the name map dot insert root digest comma slash. So we now know the name of where we are, and we're going to list things. So we get files, we get directories, we get symlinks, and we get node properties. Node properties none. Is that true for all of it? Probably true for all of these. So let's assume that we get no node properties, and let's move on. So for file in dot files, we've got a file node, print line, thing slash thing. File is a file with that digest. Oh, do files have any properties? Name, digest, whether it's executable, and more bleeding node properties. Well, I'm not going to do any node properties, but is boop file. You're going to see what I'm going to do in a sec. Okay, so our arguments are this name, file dot name, if file dot is executable, we go with unexecutable, else a, and then file dot digest dot hash, file dot digest dot size bytes. How likely is that to be correct? So we're just printing the file names out. It's going to crash immediately. So we also need to do for dir in borrow dir dot directories. So what do we get for directories? Directory node. Just has the name and the digest. So we're just going to record that into our name map. Name map dot insert dir dot digest dot clone format boom slash boom of this name and dir dot name. Symlinks. What do we do for symlinks? Name and target. Path separator is a /. The target path can be relative to the parent directory of the symlink, or it can be an absolute path starting with /. Support for absolute paths can be checked with the capabilities thing. Components ... are allowed anywhere in the target path as logical canonicization. Logic. What? Okay, fine. This is very confusing, but for link in borrow dot symlinks print line blah slash blah links to blah this name link target big pile of horror. So I can't stick a digest into a map. That seems a bit sad. There's all sorts of horror here. Method cannot be called on hash map digest string due to unsatisfied trait bounds. Pub struct digest does not satisfy EQ or hash. Method get exists, but it's trait. Okay. And while we're at it, no field size bytes on option digest. Option digest? Why would the digest there be an option? The heck? Directory file node. Why is that optional? Is that a case of a missing file would be optional there? It's weird. Okay, well, we'll deal with that. If let sum digest equals borrow file.digest. Boop, else boop. I'm just feeling super cheeky here, and I'm not going to apologise for copy-paste programming. No idea, says Adam. Okay, so the only thing that we need to do now is work out how we can make digest satisfy EQ and hash. So step one, what do we know about digest? Trait implementations, clone, debug, default, message, partial EQ, structural partial EQ, but not EQ. That's fascinating. So it derives partial EQ and message, but it doesn't derive EQ or hash. Well, bump you. Fine. We'll do it as strings. Yucky boo. So we're going to insert format boom badoop boop badoop comma root digest dot hash comma root digest dot size bytes, and then where we insert directories, it's going to be again format boop boop comma dir.digest dot hash dir.digest dot size bytes. That build. Oh, yeah, we can't get a digest like that. We're going to have to go, instead of constructing a digest object, we are going to once again format boop slash boop of sha and inc.len. And again, the directory, its digest could be optional. I do not like all of these optional objects. Oh, I wonder if it's because in theory it could not appear in the proto buffer. It could not appear. Yeah. Slash casplay 207 dot into. Okay. Move occurs because root digest has type digest, which does not implement copy. and then we try to use it there. Oh yes, because it's a string object, not a thingy. Clone. Cannot borrow name map as mutable because it is also borrowed as immutable. Unwrap there. Mutable borrow, immutable borrow. All of that is completely fair. Okay, so root should not. Do we not want? No. No, we do want to slash. No. Root should be an empty string. Am I still debug printing something somewhere? Yes, there. Let's stop that. And I think we didn't have any more page tokens either. And let's get rid of the got_dir message. There we go. That is the full set of things coming out of there. That looks reasonable and believable. There were no symlinks or anything. So how about we come back to here, we go back in, we source bin activate, we cd to /temp, and we make the magic tree. So in here we're going to have 1, 2, and 3. We're going to move temp foo to 1/word list. In 2, we're going to have a symbolic link to 1/word list. And in 3, we're going to have, what's it? So directories, files, and symlinks. So that is actually the full set of things. I'm doing 3. And then what we want to do is make it so that the page size is sufficiently small. No, hang on, that doesn't make any sense. What is page size again? Get tree request. A maximum page size to request. If present, the server will request no more than this many items. Regardless of whether a page size is specified, the server may place its own limit on the number of items to return and require the client to retrieve more items using a subsequent request. Does build grid ever reject, stop early and hand back a page token? Or am I barking up a wrong tree trying to cause it to? Hopefully I will get an answer. In the meantime, let's try uploading this simple tree. Digest is that. Cargo run ls that. So 1 word list is that file, and 2 word list is a symlink to 1 word list. So that is working. Hurrah! I'm hoping that Adam is beavering away trying to determine what I asked. In the meantime, ln-s/boobarbaz wibble. So that's an absolute symlink. If I try to upload that, it either didn't try to upload Wibble at all, or it just didn't mention it. Given it didn't mention 2/1, I'm guessing it doesn't mention them. So let's grab that digest and let's that. So we do get that absolute symlink come back. I'm assuming that just means that we're allowed to. Let's just double check. If I run caps, that says symlink absolute path strategy disallowed. What does that mean? That I could upload an absolute symlink then? That's super strange. Again, I have no idea whether or not Adam is here or rummaging in Python, so hopefully he will tell us something soon. But we're now successfully listing directories, assuming that that stream holds out. And I think it's probably reasonable to request 100 things in a page, just so that we can get things to work. And if we get that larger entry, that's still working nicely. And we could take any one of these files. Let's go for one that's relatively small. Artifacts.yaml. Cargo run fetch that digest. That's looking pretty good. Looks like it won't stop, but it will send multiple get tree response messages. Okay, cool. So there's no point me even worrying about page implementation for now, at least not while we're playing tonight. Right, so now we are 2.5 hours in, well, 2 hours, 20 minutes in, and we have successfully implemented something that deals with get tree. I'm quite pleased. I suppose the next trick is to write the upload feature. This terrifies me. Are we going to do it? Someone give me a yes, do it, or a no, let's stop. This has been going on for far too long anyway. And while you do that, I'm going to, I don't know, good recursion. Oh, hello, Peter. Sorry, I didn't see you say boo. Crates.io. Sorry for the brightness again. Read. Scander, an easier reader and recursive directory walker. Distant lure. That's amusing, right? Scander, what's this? Appears to have no README and was last updated 6 years ago. Well, that doesn't sound good. This is what I do when I'm not playing Space Engineers. Yes, last night I started to sort of look at the remote execution API because I'm a weirdo, and it was 1 o'clock in the morning when I realized I was reading build grid source code, which I perhaps shouldn't have been doing. So I thought, well, why not? Let's actually have a go and see how hard it is to just hack up a client. Obviously, this isn't nice code, but if we can hack up a client relatively effectively, then in theory, writing a nice server should be within the wit of Dan. Well, thanks for paying attention, Bob. You lasted longer than I expected. Read all? Easier. Well, let's just use the built-in directory stuff. Oh, Tokyo might have something. That could be amusing. Docs.rs Tokyo. Reader. Tokyo FS Reader. Yes. Rude? I don't know what I said that was rude. Tokyo FS Reader with a path. Right. Here we go. Upload blob. Let's be cheeky and let's go if metadata name dot is the return upload the config name dot await. And here we go. Async fn upload taking a config and a file name giving a crapshoot. So, to upload a full directory tree of stuff, we need to both be able to upload the blobs individually and upload the directory objects. So how are we going to do that? We are going to upload the blob. We'll just do an individual blob at a time. I'm going to steal most of this upload blob code and kind of futz about with it a bit. So step one, I'm going to shove that there. Actually, I'm going to go to the bottom of this code. I'm going to steal that chunk of stuff. I'm going to stick it up here. Close that, and I'm going to go async function really upload blob config name, and that's going to give us an anyhow result of a digest, because that way I can be super cheeky and go, if we've already uploaded it, we're just going to say, we're not going to do a blob already exists in the CAS. We're going to go return OK of digest of hash is SHA and size bytes is flenaz I64. And in fact, we can do that down here as well. We can just go if response dot getref dot committed size does not equal flen. Trying to remember the return error. Whoa, committed size was bonkers into. Otherwise, we're going to again just do that. And then in here, we're going to say let digest equal really upload blob config and name dot await. And we're just going to go digest.hash digest.size bytes. Things are going to get messy, but we're okay with that. Cargo build. Expected a result found. Doodah. Don't want the question mark there. Blob uploaded as, okay. And it does not like a string like that. So how do I get an anyhow error in that way? Probably that. Okay, so we're back to where we were before we started to think about writing an upload directory function. Whee! Okay, so uploading a directory is going to involve us walking a path and finding out everything about it in a useful fashion. So readdir is implemented as the equivalent blocking operation on a separate thread pool. Mumble, 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 but it does a result Tokyo FS readdir. That's a structure that has, this is a stream, async fn next entry, gives us a dir entry. That has the full path, the file name, the metadata, the file type, which is an async function that presumably lets us say, hey, is this a directory or a file? Yep, okay. So that's roughly the structure we're going to be going with. Whenever we have completed a directory's worth of stuff, we then want to upload just that blob object. How am I going to do that? Because upload blob takes a file name. We'll worry about that when we get there. Right, so walking the directory structure. Let's do this. Okay. Let's mute dir reader equals read dir of name dot await question mark. That gets us our directory reader. While let some entry equals dir reader dot next entry dot await. Do something with the entry. So presumably we need to build a directory object. So let's go let mute this dir equals directory. And fill the struct fields. Node properties, none. Symlinks. What's the type of that? Was that a vec? I think it was. So that was get tree request. Get tree. No, it's directory. Yes, so there's vec option. So that's just going to be vec. That's just going to be vec. And that's just going to be vec. If entry dot file type dot await dot is dir. So we've found a directory and we want to upload it and add it to our directories list. So we want to go upload dir config, comma, full path, whatever that is. That's going to be entry dot path. Is that what we decided it was? Dir entry returns the full path by joining the original path to readdir with the file name of this entry. No, we don't want that. I'm going to be disgusting and do this as a string, I'm afraid. So let's subname equal format thingy/thingy for the value of no thingy slash for name and entry dot file name dot toString lossy. And then I want you to do upload the config the dot join brackets entry dot file name comma subname dot await question mark. And let's upload the underscore of config and name and the empty string because we're talking about the root. And that has to return a crapshoot. No, it's worse than that. That has to return an anyhow result of a digest. And that's going to be println uploaded directory that digest is that / that name.display digest is going to be res.hash res.size bytes. Let's keep going. Right. We've uploaded a directory which has given us a digest object. So in our here we need to construct a directory node with the right name and a digest object. Okay. Let this name equals entry.filename.toString lossy.toOwned. No, .toString. Subname is just going to be name and this name. Let node equal directory node. Name is this name and digest is just digest. And so if we just go yoink and we change that to name and we change that to base name and name, we're now making a node. This dir.directories.push node. Some digest. Build. I mean, it's not going to be right, but we're going to get somewhere. Borrow the dir join. Borrow the subname. Read dir of dir. A recursive async fn must be rewritten to return a boxed din future. Consider using the async recursion crate. Ooh. Async recursion. Automatically convert an async function to one returning a boxed future. Use async recursion, async recursion. Seems nice and simple. Apparently I didn't import it. Silence on stream. Ha! Someone's come and looked. How strange. Okay, so we're now at least reading all the directories in. I mean, we're not uploading any files yet, but you know, we're getting there. And then we're going to have to canonicalize and return the directory. But let's go for the next thing, which is let's abstract out the file type. Let ftype equals that. If ftype is dir. If ftype is file. So at this point, we need to upload the file. So we're going to say doobie-doo, what's it going to be? Let digest equal really upload blob of config. The full file name that we want, so that's going to be entry.file name? No. Entry.path. Borrow that. And so that will upload the file. Now, what does a file node look like? A file node has a name, an optional digest, and is executable in the node properties. Okay, let node equal file node. I wonder who, if anyone, is watching. The name is going to be entry.filename.toString glossy.toString. Digest is going to be some digest. Is executable is going to be entry.metadata.await. Do we have an is executable? Permissions. Dot read only. This is a bit nasty. Okay. Dir entry in Tokyo FS. Nothing about executable here. Metadata returns a metadata object, which is a normal metadata object. Okay. Permissions is that Unix stuff is available through the permissions ext trait. What does permissions ext give us? It gives us a mode. I don't want a mode, I just want to know if it's executable. Set read only, read only. Rust, determine file executable. Okay, so we do have to use permissions ext and faff that out. Okay, fair enough. So let's get the permissions earlier. Node properties, let's go with none. And now let's insert that. So this dir.files.push node. How are we doing? Mode not found. This available from permissions ext. I thought I'd asked for that to be included, but perhaps I didn't. No, apparently I didn't use that. Right. If ftype.isSymlink, we want to prepare a symlink node. So let's go for target equal. How do we get a symlink target? Doobie-doo. That gives us a dir entry. Metadata. So isSymlink is true on the metadata. Created result time. So this is true for a symbolic link. How do I read the symbolic link? Do I have to separately read link? I think I do. Okay. So target equals read link of entry.path. We then need to render that as a string because everything is awful. Let node equals symlink node. Name is entry.file to string. Tell you what, I keep doing that. So let's promote that out. Which means that we can just do name there and there. In fact, name target node properties just needs to be a none. And this .symlinks.push node. We're getting somewhere. Except, of course, that needs to be name :name.clone. Name::name.clone. Name::name.clone. It's the joy of having these structs that don't borrow stuff. Right, what comes next? We've looked at and constructed a directory object of file nodes, directory nodes, and symlink nodes. The node properties is none. Right, okay. In order to ensure that two equivalent directories hash the same values, following restrictions must be obeyed. Every child in the directory must have a path of exactly one segment. We obey that. Each child in the directory must have a unique path segment. While the API is case sensitive, the environment where the action is executed may not be case sensitive. It's legal to call the API with the directory. Okay, fair enough. The files, directories, and symbols in the directory must each be sorted in lexicographical order by path. The path strings must be sorted by code point, equivalently by UTF-8 bytes. Okay. I think, therefore, what we want to do is we want to go this dir.files.sort by key given an entry entry.name, and we want to repeat that for directories, and we want to repeat that for symlinks. Is that going to compile? No. E.name right, so that doesn't automatically borrow, so I need to stick the borrows on there. Has type must outlive flip me. Well, I'm too lazy to do any more today. I could just write a proper compare, but that will do. Watch me being super lazy. Right, we've canonicalized the layout. The node properties of files, directories, and symlinks must be sorted in lexicographical order by property name. Well, we've not put any node properties in. So at this point, I think we can treat this directory proto as complete. So let enc equal this dir.encode. Was that how we encode a directory object? Encode to vec. So that gets us our directory object. We therefore know what its hash is going to be because we can compute that like that. And what we want to do is upload this. Oy, caramba. There was an operation that let us upload small things, and directories are almost certainly going to be small. And it was batch update blobs. So we could just do that. Let's do that. Let's mute client equals content addressable storage client connect config.endpoint.clone. Await. Let request equal batch update blobs request. That needs an instance name. What's the betting? config.instanceName.clone. And it needs some requests, and that's going to be a vector of something. Batch update blobs request. Vector request objects. Those are, so that is a batch update blobs request : request, which contains a digest, some data, and a compressor. The format of the data must be identity or unspecified or one of the compressors advertised by. So what is identity? Ha, excellent. We know what that is. So the digest, let's actually do that here. Let digest equal digest. Hash is sha, and size bytes is enc.len as I64. So we have the digest. I'm going to clone that actually, because I want to return OK digest here. The data is just going to be enc, and the compressor, well, what's the compressor type over here? It's an I32. Okay, and according to this, it's the compressor message identity. Ooh, goodness me, right. So this is compressor : value : identity. Equals, it's a colon. How likely is this to work? So impl value has an isValid and a from I32. Does it also implement an into? No. Ah, but they are directly assigned numbers in the Rust code. So if they're directly assigned numbers in the Rust code, I ought to be able to do identity as I32. Comes next. Digest clone. Match it in sum, line 353. Of course, because, you know, digest objects. We're getting somewhere. Okay, we haven't used client or request. Let result equal client.batch update blobs over request into inner batch update blobs response. Use vec of responses, digest and status. Okay. So if result.responses.len is not 1, anyhow, bail, whoa, didn't get the right result count. If result.responses 0.digest, it does not equal some digest. Anyhow, bail, whoa, wrong file. Result responses 0.status does not equal some goodness knows what. Anyhow, bail, whoa, upload directory object failed. Otherwise, okay, digest. So, what is a status? Code, message, details. Code should be one of the Google RPC code. Flip me, okay. If status.code does not equal Right, what's an RPC code? Google.rpc.code. The RPC error handling is a wonderful pile of joy. I agree. So it's an RPC code. So RPC code. I think we're going to have a look at that file, honestly. Google.rpc.code. Status. There's something weird here going on. So it should be a google.rpc.code. But where does that enum come from? RPC error handling is a wonderful part. So Google APIs, Google RPC code.proto. Has an enum code where OK is 0. Screw it. If status.code is not 0, that. Cargo build. I imagine that RPC status code is just not referred to by anything, and so we haven't built it. I suppose I could fix that by asking for Google APIs, Google RPC code.proto. So my next question is, did that automatically get included? Because Google.rpc is a structure. So if I said RPC : code : OK as I32, that in theory might be good, right? Cargo build. Variant not found. There is one with capitalization with a lowercase k. Of course, it did that to it. Digest moves occurs because some digest is there. If borrow that is equal to sum borrow that. No option for borrow option digest is equal to option borrow digest. As ref. You can tell it's been a long time since I've written complex Rust code. Hey! Oh dear. Should we try and upload something? Cargo run -- upload source. Cargo run -- ls. Yeah. Cargo run fetch. Well, that was terrifying, but I appear to have written the equivalent of BGD CAS upload dir in about, what, 40 minutes, including learning everything? That was fun. Oh dear, it's horribly inefficient, but I don't care. I mean, it keeps creating clients. I don't care. It works. That's amazing. I suppose, realistically, I should push this somewhere. So let's do that. Let's work out what's going on here. Modify, delete it. We should probably add Google APIs and remote APIs. Git submodule. Add Google APIs? No. Git submodule init. Git submodule. Git submodule absorb git does git submodule status. No. Absorb git does Google APIs. Did not match any files known to Git. I'm very confused, but I don't care. Google APIs and remote APIs can go away, and the clone of that can just be git submodule add. And the clone of that can be a git submodule add. Right. Modules, cargo files, build RS, the two submodules, that script, git commit. Make a commit. Right, GitHub. No, hub. No, GitHub. What's the GitHub command line tell us? GH repo create cats play public. No, no, yes. Git push -u origin hit. Okay. GitHub.com Kinnison Casplay. There is that horrible mess. If any of you that have been watching want to have a go with that yourself, you're welcome to. The shell.nix there just sets up a default env, so if you're using Nixos, it'll work. If you're not using Nixos, it doesn't really matter. For reference, I was using Rust 159, which was released yesterday. So if you manage to do this and it manages to work, then congratulations. Otherwise, I think I'm probably going to call it a night there. So thank you very much for watching. Goodbye. And we're out.